Dilations is a pretty easy topic for the most part, as long as you understand the basic idea of what's happening. Dilations are kind of like transformations where we are going to move the object, but we're not going to keep it the same size. We're actually going to make it either bigger or smaller. And we have to take a look at something called the scale factor. And if it's bigger than 1, it means we're going to make it bigger. If it's less than 1, it means we're going to make it smaller. So when we're taking a look at this object right here, my scale factor is bigger than 1, I know that my final product of dilating um, this object is going to make it actually twice as big. If we looked at it and suddenly we said that we had a scale factor of like 1/3, like I'm going to use on this other example, because it's less than 1, I know that this big triangle is going to shrink down to 1/3 of its size. Now, how do we do that? How do we actually do these dilations? Well, the first thing that you need to do is you just need to take a little bit of time and write down each point. Let's call this one point A, call this one point B, and we'll call this one point C. Point A, the ordered pair is -4, 1. Point B is 0, 3. And point C is 1, 0. That's all that you have to do to start out with this process, is go get the ordered pairs for each point. Then you literally take the scale factor and multiply each part of the ordered pair by the scale factor. So A prime is going to become -4 times 2, which is -8, and 1 times 2, which is 2. And that's where A prime is going to go. So I go to -8, +2. This is now the new location of A, and we call that A prime. 0 times 2, it's not a trick question, it's still 0. And 3 times 2, that's our scale factor, is 6. So the new location of B is 0, 6. And then we can come down to C and know that the new location for C is going to be 2, 0, because we take both of these numbers in the ordered pair and multiply it by the scale factor. Now we just connect the sides and we're done. What you will notice here is that the triangle is twice the size of the other one, and that's because the scale factor is 2. Basically, that's going ahead and telling us that it's twice the size. It's just as easy when you look at a scale factor that's less than 1, and it'll have a fraction. Sometimes it'll be a decimal number. Like if it was 1/2, they could do 0.5. They could say a scale factor is 0.5, but traditionally I see it most of the time as a fraction there. So let's go through and get our ordered pairs from these points. Let's go ahead and name them. A, B, and C. Most of the time they're named. It's just I forgot to set that up earlier. So let's see. That's -6, 0. Here's B at 3, 3. And here's C at 6, -6. So then what we have to do is go through and multiply those ordered pairs by our fraction. So 1/3 times -6 is going to be, well, let's see, this will be the new location of A prime, so I'll put A prime there. -2, and 1/3 times 0 is 0. So let's go graph that. -2, 0. Don't worry about the fact that it's inside of it. It happens quite a bit with dilation, so it'll either be on the inside or they'll overlap. It's just a hazard of the transformation here. B will be moving to a new spot called B prime, and we take these two numbers here and multiply it by the scale factor. So 1/3 times 3 is 1. 1/3 times 3 is 1 again. So B prime is at 1, 1. And now C, do the exact same thing. New location will be called C prime. 1/3 of 6 is +2, and 1/3 of -6 is -2. So 2, -2. And we just have to go through and finish connecting these. And basically what we've done is we've reduced this triangle to 1/3 of its original size. So we have dilated it successfully, and that's all that we do with dilations. It's really nothing to it. I can't think of anything that's really that much more complicated. I will note that another way that we can give you the scale factors though, and again I may have said this earlier because I paused the video and had to take care of a few things before I got back to it, so I apologize if I did, but k equals 1/3, that's just another way of saying your scale factor, that k is equal to 1/3. And also, I do want to mention this is dilations about the origin. It's a totally different set of situation when they say that you're dilating it across a different point. If it's across the origin, the 0, 0 point of this coordinate plane, all we do is take the scale factor and multiply the ordered pair by it.